Good morning, class. We are back on the internet and we are in full effect. We got some new notes coming up for you. We're talking about angles formed by intersecting chords as well as intersecting. We got a new line that's coming up today. We'll get into that in a few. First off, let's talk about what a chord is. A chord is, time to click, come on, is a segment whose endpoints are on a circle. We've dealt with one specific type of chord, and that is a diameter. So, this is going to give us a new formula for us. So, sometimes we have angles that are formed by two chords. So, for instance, we have these two angles that are over here. We have one over here on this side here. We got RTP. The other side, we got QTS. We also got these top and this bottom angle too, but that's something we can get into in a few. Now, this formula says that angles that are formed by two chords are one half the sum of the intercepted arc measures. So, specifically, when we want these, we want to look to the inside of the angle and the back side of the angle. So, if I was looking for RTP, that's this right over here. For me to figure out this measure, I would take half of the sum of this intercepted arc and the intercepted arc from the other side of the chord. Okay, so these two chords here, they made this angle. So the two chords that are intercepted are the front one and the back one here. So if I wanted to look for the other side, like RTQ, RTQ, I would end up looking at the angle that's in front of it, not the angle, the arc in front of it, RQ, and I would add it with the arc behind it, PS. So these two will come together to make this angle in the center. So depending on which angle you're looking at, that's going to bring your focus to what other angles you're seeing. So let's look at a quick example here. They're asking for the measure of LNK. LNK is this one right here. We got an arc in front of it, that's 33, and we got an arc behind it, that's this 89. So what we'll do to find LNK is we'll add those two together and then divide by 2. So 33 plus 81 divided by 2 will get you 61. Nice and easy formula for you to keep track of. Just make sure that you keep track of it as best as you can. So this was a bit new, and we're going to get into something newer. So I don't want you to panic. Take your time. We have some stuff to talk about. We're going to be talking about a tangent line. Not exactly the same tangent that we were doing back in trig, but a similar one. A tangent is a line in the plane of the circle that intersects the circle in exactly one point. So, this line over here from A to B only touches this circle right here at B. It doesn't touch anywhere else. I know it looks like it's touching somewhere else over here, but trust me, it's not. So this is a line. Along with us knowing that it touches it here, remember, lines go off forever and ever and ever into the distance. So you'll see that little arrow on one side. That arrow lets you know that this is a tangent line as opposed to something else. Now, if we have us a angle that is made up of a tangent and a chord, that is equal to one half the intercepted arc measure. So that one half is really playing a big deal for us, okay? So over here, angle B, this angle made from a tangent line and a chord inside of the circle, is half the size of arc BC. So in our example here, we got us 96. This 96 degrees is the measure of this arc. I know because they're asking us to find angle R, not the other thing, arc QR. So QR here is 96. So what we're going to do is we're going to take 96 and we're going to divide it by 2. 2 fits into 9 about 4 times, which means that we got 16. 2 fits into 16 8 times, so this should be 48. All right. Next thing that we got to know, we got a related theorem just like last time on our notes. A related theorem we have for these types of lines is that if a radius, not radius, if a line is tangent to a circle, it is perpendicular to the radius or the diameter at the point of tangency. So specifically, at the point of tangency means where, Lord, my handwriting is bad. No, I'm not going to worry about that. Restart. This point of tangency is where the tangent line touches. Do, 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 do. Tangent line touches. I guess I should probably put where. And this time I'll actually spell it okay. Where the tangent line touches is going to make us a perpendicular line. All right, let's get us a couple of examples here. We're looking at the we do it, so let's do it together. This is us trying to figure out the value of x. Now, this angle here, 87, it's made up of 2 chords, this line and this line, which means that if I wanted to figure out what 87 was, I would have added these two and then divided by 2. But since we know what this is, we're going to solve it using that information to go backwards and find that other arc. So this arc here in front, 134, and this arc here in the back, x, when I add them together and divide it by 2, it equals 87. So since we don't have what x is, we're going to have to do this in the reverse. Right now, we're dividing by 2 with our x. So that means to undo that, we're going to have to multiply both sides by 2. That ends up giving me x plus 134 is equal to 174. Since I'm adding here, I got to subtract so I can get x by itself. So when I subtract both sides by 134, my x value is 40. So this arc here, it's 40 degrees. All right, just like we did here, we got another bit of math coming on our next one. We have this angle, and it's formed up by these 2 chords. Remember what we said before. This arc here and this arc here added together, and they were divided by 2 to give us this 124. So when we set up our math, we got 9x minus 3, that's one arc, plus 197, the other arc, divided by 2 to get 124. All right, whenever you see that fraction with that denominator, we're going to do the same thing we did over here. The denominator is telling us what we're dividing by, so to undo it, we got to multiply. So I'm going to multiply both sides here by 2. These 2 cancel out just like these canceled out earlier. That leaves me with this nice little solid equation over here equal to 248. Now that we got this all handled here, we can solve this. This is a nice 2-step equation. I got to subtract that 194. That's going to give me this 54. And once I go through and do that, I divide both sides by 9, and that gives me a 6 for my answer. All right. This one has a bit more context clues that we got to be aware of. So, first off, we see this symbol. We've seen this symbol all throughout this year. This is the 90-degree symbol. So that means this is a 90-degree angle. Now, this is a 90-degree angle. Let's remember what happens when we have 2 angles on a straight line. They add up to 180. If this is 90, so is this, because these 2 make up a straight line. If this is 90, so is this, because they make up another straight line. And I guess you know where I'm going with this. It's another angle that is a right one, so that means all of these are right. So, just like we did before, we got us 2 chords here, this, and these 2 arcs, 70 and x. So that means we're going to have to add them up and divide it by 2 and set it equal to our 90-degree angle. All right, just like before, we got to get rid of that 2 on the bottom. So when we get rid of that 2 on the bottom, we are undoing that division by multiplying. So that ends up canceling each other out, giving us 70 plus x is equal to 180. I got to subtract that 70 because we want to get x by itself, meaning that x is equal to 110. First one, pretty good. Second one, we're going to have a little bit of algebra, so let's get into them. Remember, our two arcs are going to be added up and divided by 2 to equal our angle. So we got 3x plus 3 plus 10x minus 14 is equal to 53. And then, oh, sorry, divided by 2 is equal to 53. Got to remember the 2. All right, we've seen this happen all the time. I'm making sure that I write this down with this calculation here so that you understand what I'm doing. But we have to undo this division before we deal with anything up top. So I multiply both sides by 2. That gets me 106 for the other side. And when I combine my like terms on the left, I get 13x minus 11. Now I continue to solve. I deal with that 11 by adding it, and then I deal with that 13 by dividing it, which means that x is going to be 9. All right, so far so good. We had some nice easy ones with our chords, but let's do a little practice with our tangents, people. Down here below, we got us a set of angles, a set of arcs, a set of things that are made up of some tangent parts. So we got to be good and take our time with this. First one that we got here, we got to figure out what is y and what is x. Now, first off, what is y attached to? Y is attached to this big arc here. And this y is attached to this smaller arc here. Now, what do we remember a circle adds up to in terms of degrees? It adds up to 360. So we got to add these two expressions together. We got y plus 3y equals 360. Y and 3y give me a 4y. And when I divide those guys by the 4, my y's end up with 90. All right. Now, if this down here, y is 90, up top, this is 3 times 90. 3 times 90 is 270. Now, this x here, this is made up of a chord and a tangent line, which means that this thing is half the size of this angle. So for me to go from here to here, from this arc to this angle, I got to divide by 2. So when I do that, half of 270 divided by 2 is 135. So my x is 135. Okay, next one here, they want us to solve for x. Now, what do I see inside of here? These three angles are a part of this shape, a triangle. And I also see that one of the sides of this triangle is a diameter, and the other side, this is a, what's the name of that thing? A tangent. So when a diameter hits a tangent, they hit each other at a 90-degree angle. So that means that this is 90. If this is 57 and this is x, all three of the angles are going to add up to 180 next. So I got 90 plus 57 plus x is going to equal 180. I could buy my like terms, and then I subtract them from the other side, which means that x here is going to equal 33. Pretty good. All right. Now, let's jump into our next thing. We have another set of tangents here outside. This tangent and this tangent, they are both touching the circle at one point. And this is a radius with another radius. So that means these hit these tangents at a 90-degree angle. Now, when we deal with a four-sided shape, for all four sides here, these are going to add up to 360, just like these arcs did. This is just a property of four-sided shapes. So I got x plus 119, that central angle, plus 90 plus 90 plus equals 360. When I add these two together and subtract it, that ends up giving me an x of 61. Folks, thank you for watching, and I will catch you on our part 3.